in this problem, we want to replace these two forces, the system that consists of these two forces at these two locations, with an equivalent system with just one resultant force and one resultant moment acting at point O. Okay, so first thing we need to do is figure out what that resultant force would be for an equivalent system acting at point O, and that's simply by adding the two forces together. So I have F1, which is 6i minus 3j minus 10k, and F2, 2j minus 4k. Just add those together, and you get a resultant force acting at point O of 6i minus 1j minus 14k. Okay, so taking those two forces, moving in point O, that would be the resultant force. When I do that, when I move those forces, I need a resultant moment to to create an equivalent system. Okay, and that resultant moment is found just by taking r cross f of each force. Okay, so I go from point O to both force 1 and force 2. So r from O to force 1 is 1.5 in the x and 0.15 in the x and 0.3 in the z. So I have r here of 0.15 and 0.3, crossing that with 6, negative 3, negative 10. That's F1. So that is one part of the resultant moment. The other would be going from point O to force 2. To do that, I go in the negative y direction, 0.25, and then up in the z direction, 0.3. So negative 0.25j plus 0.3k. That's my r vector from O to force 2. So I cross that with force 2, which is 2j minus 4k. Okay. So I take those two those two r cross f's, add them together to get my resultant moment. Now, I could replace this system with a system acting at point O of a force of 6i minus 1j minus 14k, and a couple moment acting at point O of 1.3i plus 3.3j minus 0.45k, which would be the exact same external loads that it would be equivalent to having these two forces at these two locations. Okay, so I have an equivalent system to these two forces with just one force and one moment acting at point O with these magnitudes.